The quadratic formula is generated from the quadratic equation y equals ax squared plus bx plus c. The quadratic equation allows us to solve for the x-intercepts and gives us the x values of where the graph of that function crosses the x-intercept, or the x-axis. This is the quadratic equation. X equals the opposite of b plus or minus the square root of b squared minus 4 times a times c, and that whole thing is over 2a. Please note two things. The first thing is that the radical sign is over all of b squared minus 4ac, and that the whole problem is divided by 2a. So you figure out what the numerator is first, and then you divide it by 2a. So let's look at an example. Let's solve for the x-intercepts of the quadratic equation y equals x squared plus 3x plus 2. The first thing I would do is identify a, b, and c. A and b are always the coefficients of the quadratic and the linear terms, and c is always going to be the constant. So there might be an instance where we don't have an a or b or c, and then that is going to change the whole quadratic formula. Alright, so a in this case is 1 because there's a little 1 right there, b is 3, and c is 2. So we're going to do x equals the opposite of b. Well, b is positive 3, so it's going to be the opposite of positive 3 plus or minus the square root of b squared, which is 9. I do that in my head just in case if it's negative. I know I'm never going to get a negative b squared value. Minus 4 times 1 times 2. And that whole thing is all over 2 times a, which is 2 times 1, so it's just 2. Alright, now we can simplify the inside by doing 9 minus 4 times 2, which is 9 minus 8. So this turns into negative 3 plus or minus the square root of 9 minus 8, which is 1, all over 2. Alright, so what is the square root of 1? Well, that is 1. So you have negative 3 plus or minus 1 over 2. Alright, so this is where it can get a little confusing. The plus or minus is because this problem is going to have two x-intercepts. So you have to go through the problem using the addition sign. Then you have to go through the problem using the subtraction sign. Doing that those two times allows you to get two x-intercepts, which this quadratic function has. So negative 3 plus 1 is negative 2, divided by 2 gives us a solution of negative 1. Then negative 3 minus 1 is negative 4, divided by 2 is negative 2. So those are our two answers. It's going to cross the x-axis at negative 1 and negative 2. Please note that when I did that problem out loud, I did the numerator first and then I divided by 2 last. Let's look at another example. Let's find the x-intercepts of y equals x squared minus 2x. First thing I'm going to do is identify a, b, and c. Alright, so my value of a is 1, b is negative 2, and then c is actually 0 because there's no constant over here. So that's okay, it's 0. So going through the quadratic formula, you're going to have the x equals the opposite of b. Well, b is negative 2, so the opposite of negative 2 is just positive 2. Plus or minus the square root of b squared, which is negative 2 squared, which is going to be 4, minus 4 times 1 times 0, all over 2 times a, which is 2. So we're going to get 2 plus or minus the square root of, and then we're going to have 4 right here, but then negative 4 times 1 times the 0 is going to get 0, so we just have the square root of 4, because it would be 4 minus 0, all over 2. Alright, so this is going to give us 2 plus or minus 2 over 2. Well, I'm going to do the numerator like this first for each the plus and then the minus, so I can get two solutions. 2 plus 2 is 4. Divide that by 2. X equals 2. 2 minus 2 is 0. Divide that by 2. X equals 0. So those are two solutions. Alright, let's look at this next example and identify A, B, and C. A is 4, B is also 4, and C is 1. Alright, now we're going to have X equals the opposite of B, which is minus 4, plus or minus the square root of B squared, which you can either write 4 squared, or in your head, like I do, you can do 16, because you know that, minus 4 times A, which is 4, times C, which is 4. I'm sorry, which is 1. All over 2 times A, which is 8. Alright, now we have 4 times 4, which is 16. So under the radical, which is that square root symbol, we are going to have the square root of 16 minus 16, which is 0. This is totally okay, and I'm going to show you what's going to happen. What is the square root of 0? Well, that's 0. So technically we have minus 4 plus or minus 0 over 8. Well, what's negative 4 plus 0? Negative 4. What's negative 4 minus 0? Negative 4. So we just have one solution. Negative 4 over 8. However, we can reduce this, and our solution, which is our x-intercept, which is our 0, is negative 1/2. So we only have one solution in this instant, and that's okay. This means that if I were to sketch the graph at negative 1/2, let's say that's right here, my function touches there and just goes up from there. So my quadratic doesn't go through twice, it goes through only once at negative 1/2. Alright, this is going to be our last example. When we have the quadratic y equals x squared minus 1. So A is 1, B, there is no B, and that's fine, it's 0. And C in this case is negative 1. So let's see what this does. Alright, x equals the opposite of B, which is 0, plus or minus the square root of B squared, which is still 0, minus 4 times A times C. Please don't stop just because you notice B or C is ever 0. You will get a solution, something will happen. Not all the time, but you need to do the whole quadratic formula so that you can see. Because in this case, we are going to get an answer. All over 2A, which is 2. Alright, so then we have x equals, well, 0 plus or minus. So 0 plus or minus is just 0. Then you have the square root of 0 minus 4 times 1 times negative 4 is just 4. And then you have it over 2. Now the one thing I forgot to add in here is that we do need to have our plus or minus. So let me put that in here. Plus or minus the square root of 4, which is 2. So we have plus or minus, square root of 4, which is 2. So we have plus or minus 2 over 2. Well, 2 over 2 is 1. So our two answers are 1 and negative 1. The last thing I want to point out is you are never going to have a quadratic equation where a equals 0. And this is because if that was true, you would have y equals 0x squared plus whatever b is plus whatever c is. And what is 0 times x squared? Well, that's 0. So all of a sudden, my function now turned into y equals bx plus c, which is a linear function. So a can never equal 0 in a quadratic formula because the function would no longer be quadratic.